So how'd you do in the lab exercise? Did you find it challenging? Let's go ahead and go over the results right now.
This video is brought to you by ObbyPies Academy.
I've got the results for the first part of the lab open here on my screen. Let's just run it real quick, make sure it works correctly. So I'm going to move from desktop to my Python folder. And let's see, there we go, Python. And in the Python folder, I've got this file, io.varslab.py. So let's run that with the Python command, io.varslab.py. Again, using autocomplete to make it fast. All right, and there's our result. I am 41 years old. My name is Mark Lassoff. In school, my GPA was 3.33. So, of course, that's generated by these three lines here. I am, and then we have our operator right here, blank years old, and then we use dot format age. That retrieves the variable age, which has a value of 41, giving us I am 41 years old. The string name has my name in it. Notice the string in quotes. So when we replace this with name using the format command, we get Mark Lassoff. In school, my GPA was, and then we have our operator, and then format GPA, which gives us 3.33, just as you see right here in the command line. All right, so now comes the more difficult part. First time through, I want you to just set the variables to 27.882 and 258.03. Right, you can see the values right here. And I warned you, don't hard code the values here in the string. Like, don't put here, what I meant by that, don't put here 27.882, but instead use the format command, because this way when we change the variables, you're only going to have to make that change in one place. So with the first two values, your output should have looked something like this. 285.912, negative 230.148, 7194, etc. So these were the values you got, and you should have printed out the entire problem. So you should have used 3 of these operators in each print statement, and then in format separated operand 1, operand 2, and then the expression operand 1 plus operand 2, and separate those by commas. So same thing for the next line, operand 1, comma, operand 2, and then the expression operand 1 minus operand 2, again, all separated by commas. So that's what gave us that result. Then I said, okay, let's change up the numbers to 978.425. So obviously we're dealing with floating point numbers here, and 0.0324. Now, it doesn't actually matter what numbers we put in here because we've used our indirection and are substituting the variable name for the number. So whenever we change the numbers, all of these formulas still work. Can you imagine what a pain it would be to change all of these values each time? All right, and then we talked about our friend modulus, which is the remainder after division. And I asked you to create 2 problems here. The first is 9 modulus 3, and that yields 0 because 9 divided by 3 has no remainder. However, the second line right here, where we said 112 modulus 10, does have a remainder of 2, right? 10 goes into 112 11 times with a remainder of 2. So you can see right here, we have 112 modulus 10, remainder 2. I know you probably love all of this math. I promise you this is the last chapter that's going to be so math heavy. But once you understand these basics, that's really it. You don't need to be a mathematician to work in programming. All right, so let's take a look at part 2 with the Pythagorean theorem. Now, admittedly, if the Pythagorean theorem was long forgotten for you, like it is for many, I'm sure it probably took you a little longer. Okay, so let's open up our source code for this next part here. So File and Open in our idle Python development environment. I've got the Python folder on my desktop, and I called it pythag.py. Great. Let's clean up our windows a little bit here. We don't need quite that much width. It's a short little program that does this. All right, let's run it and make sure it actually works. So bring up our terminal here, and that one's running idle, so I guess we'll need a new terminal window. Perfect, and I'll make that a little bit bigger. All right, so let's run the program. So inside our desktop and inside our Python folder, we've got the Pythagorean theorem program. So length of side A, let's say 4, and length of side B, 3. So calculate the length of side C should be 5. Let's run it one more time. Length of side A, let's say 25. Length of side B, let's say 119. Length of side C should be 121.59, etc. So seems to work. The answers seem to make sense. Take a look at the code. So first thing, and I told you to do this, is import math. That lets us use this math library, which includes the square root function. So math.square root. So import math. And I told you to do that right there in the instructions. Now we want to get the user to input side A and side B. So we use side A equals input what is the length of side A, or something like that. And side B equals input, and then the prompt in the parentheses, what is the length of side B. So whatever the user entered for side A is stored in the side A variable, and whatever the user entered for side B is stored in the side B variable. So you'll recall that the formula is a squared plus b squared. So squared just means something times itself. So I said side C equals side A times side A, and I use parentheses for clarity, plus side B times side B. So side A is multiplied by itself, side B is multiplied by itself, and it's added together. That gives me C squared. But I need to take the square root of that with math.square root of side C. And then I output the length of side C to the user, again using my format and print command. So this is the application of Pythagorean theorem, and we've actually got a program now that does something useful. So I hope you enjoyed the lab. This one, again, designed to be a little tough. If you got it right, congratulations. If you got close, I appreciate the effort. If you have any problems with this, I'd suggest you study the code again and try and get it working, because the feeling of success you'll get is just awesome. All right, we'll see you in the next chapter.